So today we'll be talking about the section B of IEB Paper 1, May-June 2022. Okay, so the first question, which is the question 7, is all about financial maths. Let's get into it. So question 7 says the market value of John's house has increased at a constant annual exponential rate of 4.5%. since he bought it on 1st January 2008. On 1st January 2021, his house was worth 3.5 million. Determine what the value of his house was on 1st January 2008 when he bought it. Now, this is a compound interest question. Now, we have the accumulated amount because this is the amount the house was worth after a period of time. So it is 3.5 million is the accumulated amount. We have an interest rate of 4.5%, which can be written as 0.045. Our principal is what we're trying to get because we're trying to find the value of the house at the beginning, right? So he bought the house in 2008. So that's the beginning of the time the house started to increase in value. Then our N would be, so this is 2021 minus 2008. So that makes it 13 years. Using the compound interest formula, which is this, substituting relevant values. Okay, so if you put this in the calculator, it gives us so it is 1,947,950.75 cents. Is it 45? 45, yes. 75, sorry about that. 75 cents. Okay, so this here is 75 cents. Okay, 1,974. 1,974. Okay, let's change that real quick. 74. 1,974,950.75. So the next question B. Helen also bought a house on the 1st of January 2008. This house, which is our house, cost 1.8 million. Its market value was seen to steadily increase, but at a higher constant annual exponential rate, which is of 5%. If the house continues to keep increasing in value at respective rates, in which calendar year will the two houses, that means the one for Helen and the one for John, be the same amount? Okay, so what we can say here is that we can look at it as this. I'm going to draw something like here. Now, on the left hand side of this, I'll call this for Helen, and on this side here, I'll call this for John. Now, we understand that Helen's house is worth 1.8 million, meaning that the principal would be 1.8 million. It would mean that for John, from the previous question, his house was worth 1,974,950.75. Okay. The interest rate for Helen, we're giving it to be 5%, so we can represent it as 0.5. And for John, it was 0.045. Now, the accumulated amount would be the same. So the A for Helen should be equal to the A for John. The reason why we said that is because they're asking us that at which year will the two houses be what the same? So that what the same means that they should be equal. And also we are told that the n is what we're trying to get, right? That what year will these two values be equal, right? So what we're going to use here is compound interest. So we would say that the accumulated amount for Helen will be equal to the accumulated amount for John. So using the formula for the compound interest, we can say that this here is P 1 plus I to the power of n is equals to P 1 plus I to the power of n. Okay, so let's substitute these our values. We're going to get now grouping like terms by dividing, I'm going to get and this here would be now on the right hand side, because our fraction, the numerator and the denominator has the same n, it can be written as okay, so let us divide this and simplify it as best as we could. We would have 1800. Okay, so this here is 0,911. 0,911 dot, dot, dot. Now, to get our value for n, we need to use logs. So using logs, we can rewrite this to n is equals to the log of, let's see if we can simplify this also. Let's see, 1.045 divided by 1,05. So that's 209 over 210. Okay. So the base will be 209 over 210, and the value would be 0,911. Okay. So we need to put all this into our calculator. I'm going to say the log answer, the previous answer, I think is this. So n would be 19,43. Now, since this was 2008 was the original period these houses were evaluated, if you add 19 to 2008, you'll get 2027. So your final answer will be 2027. And that's it. So moving on to question 8. This question says the numbers 7, x, y are in a geometric sequence. If the sum of these three numbers is negative 2x minus 7, determine the values of x and y. Normally with questions like this, whereby you have two unknowns, there is a huge possibility you're going to use simultaneous equation. And for you to use simultaneous equation, you first of all need two equations, okay? Let's try as much as possible to break down the information we're given in this question. So we understand here that this is a geometric sequence. And with any geometric sequence, there is always a common ratio, meaning that T2 over T1 should be equals to T3 over T2. Okay, so if that's the case, if your first, second, and third are given, we could say that x over 7 is equals to y over x. And we can cross multiply so it makes sense a little bit to us. This gives you x squared is equals to 7y. Remember how I said we need simultaneous equation? I could consider this my first equation. And the next thing, we're also told that the sum of the first three terms gives you this. So how about we add all three? So if we say 7 plus x plus y, they should give you negative 2x minus 7. Okay, you can try as much as possible to simplify it, moving everything to the right hand side. You're going to get y is equals to negative 3x, and that there will be negative 14. And this could be represented as your second equation. Now that we have two equations, we can do simultaneous equation and it will help us get our answer. So since the second equation is actually written nicely, we could actually just substitute it into the first. So that there will give you x squared is equals to 7, open bracket. Now we write the value of y. Since we say y is equals to that, negative 3x minus 14, I write that down. Okay, then opening out the bracket and simplifying, this will give you this is correct, 7 times 14. 7 times 14. 98, yeah, that's correct. 98. Now I move everything to the right hand side. This here will give you okay, so since it's a quadratic equation, which happens to be a trinomial, we can factorize this and you'll get there you go. So the answers for x are x is equals to negative 14 and x is equals to negative 7. Now to get your values for y, we need to take these two values and substitute that in there, right? More or less, substitute those two values in there. So you're going to get y is equals to, let's start with negative 7. So this here is negative 3, negative 7, minus 14. This gives you 7. So y here is 7. And for the second one, negative 3, negative 14, minus 14. Okay, so let's replace this here. So negative 14 will gives you 28. So we have here as y is equals to 28. Okay, so those are your values for x, negative 14 and negative 7. And the values for y are 7 and 28. And that's exactly what they wanted for this question. Now B, this question says arithmetic series has a common difference of 5. Okay, so that first sentence tells me that I should be working with this formula. Let's write that out first of all. Okay, now we were also told here that the common difference, that's this d over here, represents 5. Now, the rest of the question says the sum of the first n terms is 160. What that means is Sn is equals to 160. We were also told that the sum of the first two n is 725. Okay, so this here means S2n is equals to 725. Now determine the values for n. Okay, so if we're going to use the information we're given, we were told in the first one here that Sn is equals to 160. So using the formula for this, I could rewrite this as 160 is equals to n over 2, 2a plus n minus 1. And when I have d, I substitute 5, and I try my best to simplify. Now, because this is n divided by 2, I can move it over to that side, or multiplying both sides by 2. This here will be 320 is equals to n, open bracket, 2a plus 5n minus 5. Okay, I can open out the bracket again. I'll have 320 is equals to 2n, so it will be plus 5n squared minus 5n. Okay, so this is what Sn is equals to 160 actually gives us. Now for the second part of our question, which is S2n. Now for S2n, this is what we're going to do. Now our n will be represented as 2n over 2, and this here will be 2a plus, now the n inside becomes 2n also, minus 1, and the d is 5. Okay, so simplifying this, you're going to get 725 again is equals to n. This here is 2a plus, multiplying the inside bracket, we're going to get 10 and minus 5. Now we'll multiply the outside bracket. This is 2an plus and 10n squared minus 5n. And you have this as 725. Okay. Now, both equations can be rewritten as 2n is equals to. The reason why I'm doing this is that it eliminates the a in this equation, in both equations, right? So what I mean by that is I'm going to write this as 2an is equals to 320 minus 5n squared plus 5n. I do the same thing for the other equation. I could write it as 2an is equals to 725 minus 10n squared plus 5n. Now, because we can say this could be my equation 1, that could be my equation 2. Now, since 2an is equals to this and also equals to that in my two equations, I can equate both equations. So I have this plus 5n is equals to 725 minus 10n squared plus 5n. Okay, so simplifying all this, you would get 405. The 5n and the 5n cancel out. You're just left with minus, and this here is 5n squared. That's it. Is equals to 0. Okay, so dividing both sides by 5, you get n squared minus 81 is equals to 0. So it's n minus 9. N plus 9 is equals to 0. So my two answers are n is equals to 9 or n is equals to negative 9. So since n cannot be negative, that's just my answer. N is equals to positive 9. And that's exactly what they wanted for this question. That's it. So moving on to question 9. Now this question says, in the diagram below, the graph of fx is equals to ax squared plus bx plus c. Gx is equals to x plus 8 are given. Now we're told that O represents the origin. Okay, so this is our graph over here, right? This here is our origin. We were given the parabola. So fx is the parabola here. And the straight line, we're given the equation of the straight line, which is x plus 8. I think there's a coordinate here as negative 2 and 4. We have an axis of symmetry. I think that's what I said here. The equation of axis of symmetry of our parabola is x is equals to negative 1, right? The line that divides the graph into two equal parts. We're given one of the x-intercepts for our parabola to be negative 4. We're not given the second, but I think we probably can find it. And so I think that's it. Let's get into the questions. So let's get into it. So A says determine the values of A, B, and C. Okay, so the A, B, and C comes from the equation of your parabola, right? So the equation of our parabola looks like this. So we need to kind of put it into this format. Now, to help us get this, since we do not have the turning point, we try to figure out what this x-intercept for the second x-intercept for your parabola is, so you can use that to help you calculate your answers. Since the axis of symmetry, which is the line that divides your parabola into two equal parts, is negative 1, it tells us that the distance from this x-intercept to this axis of symmetry is 3 units. And if this is 3 units, it means that this other part to the second x-intercept should also be 3 units. Okay, so if that's the case, this x-intercept will be represented as 2 and 0 because this is 3 units from -1. Okay, now using the x-intercept form to help us get the equation of our parabola, we could say y is equals to a x minus x1, x minus x2. Now, your x-intercept, substituting them in there, that's -4 and 2. So this will be represented as +4. This is represented as -2. Okay. Now, to get our value for a, we need to substitute another point. Another point that is on our parabola, and we're given this one here, -2 and 4. So let's put that in. This here is 4 is equals to a, -2 plus 4, and this here is -2, -2. Okay, so in that case here, this is 4, this is a, this is -2, +2 actually, and this here is -4. Okay, simplifying this one over here will be a -8 is equals to 4, so it will mean a is equals to -1/2. So if that's the case, replacing our a, we'll have -½ x plus 4, x minus 2. Expanding the brackets is going to give you x squared plus 2x minus 8. And multiplying this will be -½ x squared minus x plus 4. Okay, so that will be your equation for fx. So obviously, that's your a, that's your b, and 4 is your c. That's it. Now B says it is given that fx is equals to -½ x squared minus x plus 4. Determine P and Q by completing the square. Writing f in form of fx is equals to a open bracket x plus p close the bracket squared plus q. Okay, so we want to do completing the square. The concept of completing the square is you need your x squared to have no coefficient. So we do that by bringing out the coefficient here. So I can write this as -½ open bracket x squared. This here would have to be +2 plus 4. Okay. Now after we remove the coefficient of x squared, the next step is to add and subtract ½ b squared. Right? So doing that, this here will give you -½ I'm going to change the quality of the bracket. So this is x squared plus 2. Okay, so I made a little bit of a mistake here. This here should have been 2x, okay? That's it, yeah. So continuing this, now I'm going to add ½ b. So it is ½ times 2 squared. I'm going to subtract, do the exact same thing, ½ times 2 squared. Then close this bracket plus 4. Okay, so this here is ½ x squared plus 2x plus 1 squared minus 1 squared plus 4. Okay, so if you factorize this 3, they will give you this x plus 1 squared. Okay, so you're only left with this minus 1 plus 4. Now all you now need to do is open out the square brackets. This here will be -½ x plus 1 squared. Multiplying that there will give you +½ plus 4. So this here is -1/2 x plus 1 squared, and that will be plus 9/2. So in that case there, this is your q, and -1 here is your p. And that's it. So question 2 says give the value of x for which 4 is less than fx and less than 9/2. Now, so let's try to break this down. Obviously, fx means y. So we're looking for the x value that falls between 4 and 9/2. Now, these are two important points. If we go back to our curve, we actually see that the y-intercept, right, we got in the previous question, is also 4. Okay? Now, the turning point, that's this point over here, is 4.5, or in this case, 9/2. That's the y coordinate of your turning point. So which x values falls within that range? Now, if I draw a straight line, if I draw two horizontal lines from y is equals to 4 to y is equals to 4.5, we need to focus on the x values that fall within this range. And the x values is going to be from -2 down to 0, right? But it is not equals to -1. The reason for that is in the question. So now I will say my answers are x is between -2 and 0, right? So we would say that x is greater than -2 but less than 0, because when x was -2, y was equals to 4, and when x was 0, y was also equals to 4, right? So it's just a little bit less than 0 there. Now, we would also have to make the distinction to say that x is not equals to -1. And the reason why we say x is not equals to -1 is because y is equals to 9/2 when x is equals to -1. Okay, now since our question only wants it to be less than 9/2, we understand that it cannot be this value. So this will be our two answers. -2 is less than x, less than 0, while x is not equals to -1. Okay, I could clean all this out. So we only have the answers that are important. That's it. Now for C, it says determine the values for x for which fx times gx is less or equals to 0. Okay. Now, to answer this particular question, we need to understand what this here means, less or equals to 0. What this means is, first of all, we're looking for the part of our graph that is less than 0 and also equals to 0. Less than 0 literally means it is negative, and equals to 0 actually means the x-intercepts. Okay. Now, we would say to get a negative value, the two graphs that we're multiplying, because this is the y for f and the y for g, fx needs to be negative and this will be positive, or the fx needs to be positive and that they'll be negative. So that when we multiply them, you will get an overall negative sign. Okay, so now to answer this question, your focus should be on the x-intercepts, right? The x-intercepts, put at the back of your mind. So let's go back to our graph. Okay, so we need sections of our graph where one part of our graph is negative and the other part is positive simultaneously. Okay, so now as I said, focus on the x-intercept. So if I focus on my parabola and I look at the part that is negative here, so my graph is negative here and is negative there. Now if we focus on the g and we look for the part of our graph that is positive, it's going to start from here and up there till infinity. Now, looking at this, we understand that at -4, our parabola goes into the negative. At -4 for our straight line, it will be somewhere maybe around here. We can see that the value for our straight line is positive. So now it keeps on being positive until it gets to its own x-intercept, this one over here, which happens to be 8. Okay, while this would continuously be negative, and it's going to keep on going to negative to infinity. The part in which our two graphs intersect is from -4 to 8. The straight line is positive, the parabola is negative. So our first answer can be written like this. X is an element of -8 to negative 4. Now, in the second part of our answer, we can look at for the other side here from 2. As you can see, this moves into the negative, right? Still negative. But at 2, which may be somewhere around here, that there will be positive. And it's going to keep being positive to positive infinity. And this here will keep on being negative also to positive infinity. So our second answer would be x is an element of 2 to infinity. Okay? There is no part of our graph where the parabola is positive and the straight line is negative, because as you can see just above the graph from negative 2 to 4, you can see your parabola here is positive, and this one over here is also positive also at the same. So we'll say these are our two answers. X is an element of negative 8 to negative 4, and x is also an element of 2 to positive infinity. And those will be our answers. That's it. So D says calculate the minimum length of a line segment MN parallel to the y-axis that can be drawn from G to F. Okay. Now, the reason why they use this phrase, parallel to the y-axis, means that this line segment MN is a vertical line. Now, that is because the y-axis is a vertical line. So any line parallel to a vertical line is also a vertical line. Now, when you want to get the length, right, before we get into the minimum, when you want to get the length of any vertical line in function, we always take the top graph. Yeah, so the length is normally calculated by saying the top graph minus the bottom graph. Okay, so now since G is on top, we are saying that Gx minus Fx. That there would give us the distance of Mn. Okay, so before we get into how to figure out what the minimum length is, we need to first of all figure out what the length is. Okay, so how we'll do that is, so the equation of Gx is x plus 8, and the equation of Fx is negative half x squared minus x plus 4. Okay, so opening out the bracket, you're going to get 8 minus 1 over 2x squared plus x minus 4. Okay, so simplifying this here, this will give you 1 over 2x squared plus 2x plus 4. So we'll say the length of Mn is this. Okay, so we have half of our question done. They didn't ask us for the length of Mn. They actually asked us for the minimum length. Now, whenever you have minimum, this should remind you a little bit of calculus in paper 1. And whenever you're asked to get the minimum or the maximum of any value, it is always saying that the derivative is equals to 0. So if I can get the derivative of Mn and say it's equals to 0, then substitute the value I get back into the original equation. That is your minimum length. Okay, so I'm going to say the derivative of this is equals to 0. So therefore, the derivative of Mn is x plus 2. Okay, so now we'll say that x plus 2 is equals to 0. So therefore, x is equals to negative 2. To get the minimum length, I will take this negative 2 and substitute it into the original equation of Mn. Okay, so 1 over 2 negative 2 squared plus 2 negative 2 plus 4. So definitely our minimum length would be equals to, this here is 4, that makes that 2, then this here is negative 4, and that cancels out. So our minimum length is 2 units. Yeah, and that will be your answer. That's it. Question 10. Determine the quadratic function of x that has the following properties. The first property, the function is symmetrical to y is equals to ax squared minus 7x plus c about the y-axis. The second property, the function is symmetrical about x equals to 1. And the third property, the function has a value of negative 20 when x is equals to 4. Okay. Okay, so let's get into the question. Now, the first statement says that this is a quadratic function. Now, every quadratic function has this following equation. Y is equals to ax squared plus bx plus c. Okay, so that will mean that we need to figure out what our a, our b, and our c means. Okay, that's what we're trying to get in this whole question. Now, it tells us here that the function is symmetrical to y is equals to ax squared minus 7x plus c about the y-axis. Now, this literally means that it is reflected about the y-axis. Our function, which is this one over here, is a reflection about the y-axis of this function over here. A reflection about the y-axis means that your x and y would normally change into negative x and y. Okay, the x value changes from positive to negative or vice versa, or your y stays the same. So our new function is actually going to look like this. So therefore, so what we got from this first property is that our b is positive 7. So remember, this is where we start from. And so far, we have b, but we still do not know what a and c is. That's where the second property comes in. Now it says the function is symmetrical about the x equals to 1. And whenever your function is symmetrical about a specific vertical line, it actually means that that is your axis of symmetry. Okay, so x equals to 1 is your axis of symmetry. Another word for axis of symmetry is the x value of your turning point. And if you do remember, the formula for x value of your turning point can be gotten by saying negative b over 2a. So we can actually use this to help us calculate our a. Now, if our x value of our turning point is 1, our b is 7, so we can say that let's use this to find our a. So cross multiplying, you get a is equals to negative 7 over 2. Now let's update our equation. Our equation is y is equals to negative 7 over 2 x squared plus 7x plus c. Okay, we're almost there. Now we see we have a, we have b, we're left with c. Now c, that's where the last property is going to come into play. Now the property says the function has a value of negative 20 now when x is equals to 4. So what this means is that the coordinate is 4 and negative 20. So it means that x is 4, y is negative 20. Now we can substitute this coordinate into our updated equation. So this can be written as negative 20 is equals to negative 7 over 2, 4 squared plus 7 to the 4 plus c. So we can put all this in the calculator. So this would be 7 over 2 4 squared plus 7 4. Yeah, so that's negative 28. You get negative 28 plus c, and this here is negative 20. I move that over. That will be negative 20 plus 28 is equals to c, so c is 8. So the actual equation is y is equals to negative 7 over 2 x squared plus 7x plus 8. Yes, and that's exactly what they wanted from this particular question. And that's it. Question 11. Now this question says in the diagram below, the graph of fx is equals to negative x cubed plus 5x squared minus 3x plus d, where d is a constant. It is given. Now we're told that 3 and 0 is a stationary point. Now O represents the origin, which we see over here. So this is our graph. We can see our stationary point, which is also our turning point for this cubic function. Okay? Now they ask us to get the value for d. Now d here is the y-intercept that you have over here. So since we have a coordinate of our cubic function, we can substitute that and hopefully it helps us get our value for d, right? So the coordinate here is going to be 3 and 0. So I'm just going to put in 3 and 0 into my equation, okay? So this is negative 3 cubed plus 5 3 squared minus 3 plus d. Now this here is equals to 0, right? Because the y coordinate was 0. So simplifying all this, you're going to get so therefore d is equals to negative 9. Okay, so that will be the first question. And the second one says determine the gradient of the tangent to the curve at the point of inflection. So there are multiple things going on in this question. The first part is this here, determining the gradient of a tangent. To find your gradient of the tangent, it is m is equals to the derivative, right? So whenever you get your derivative, substitute the x value, it gives us the gradient, okay? The second part of our graph here is the same, the point of inflection. And we normally get our point of inflection by getting the second derivative is equals to 0. So that's what we start with, right? We get our point of inflection for our equation. So the original fx is equals to negative x cubed plus 5x squared minus 3x, and our new d is negative 9. Okay, so getting the derivative, this here is negative 3x squared plus 10x minus 3. Getting the second derivative, this here will be negative 6x plus 10. Okay, so to get our point of inflection, I'm going to say negative 6x plus 10 is equals to 0. So it becomes negative 6x is equals to negative 10. So therefore x is equals to 10 over 6 is 5 over 3. Okay. Now, using the second part of our equation, since we said the gradient is equals to the derivative, we substituting the value for x of it. So now if our point of inflection is 5 over 3, all we need to do is put in 5 over 3, right, into our first derivative. It gives us the gradient at that point, right? So substituting this here, you're going to get 3, 5 over 3, this is negative by the way, squared plus 10, 5 over 3 minus 3. Okay, so substituting all this, you're going to get negative 3, 5 over 3 squared plus 10 bracket 5 over 3 minus 3. So that gives you 16 over 3. So the gradient of our point of inflection would be 16 over 3. And that's the answer. Okay. Now C says determine the value for x for which your graph is concave up. And normally how I do find concave up is to first of all figure out what our point of inflection is, which in this case here is 5 over 3. This part of our cubic function, I normally consider it as concave down, while this part is being considered as concave up. So if this is my point of inflection and the question is asking us for concave up, I would say because the concave up of our graph comes before the point of inflection, I'll just say my answer is x is less than 5 over 3. Okay. And if they ask us for the concave up, for this particular graph, I'll just say x is greater than 5 over 3. That's it, right? That's how I look at questions like this. And finally, with question D, it says the equation of fx minus k plus 3 is equals to 0 has 3 real roots. What are the possible values for k? Now, before we get this particular question, we need a couple of things. We need to find out what the turning point is, okay? So I will get into the question, but I need to figure out what my turning point is. Now, from here already, we see that one of the turning points is 3 and 0, but we do not know what the turning point here is, and it is very important in us finding our answers. Okay, so getting the turning point, this is what we're going to say. It is the first derivative, which we actually got in this question already. Right, so it is the first derivative is equals to 0. Okay, so it is negative 3x squared plus 10x minus 3. Okay, so negative 3x squared plus 10x minus 3 is equals to 0. Did I write that correctly? Is it? Yes, I did. Okay. Okay, so factorizing this, we're going to use our calculator, so that's a little bit faster. My calculator can factorize. I'm going to go to mode 5 and 3. Okay, so A is negative 3, B is positive 10, C is negative 3. So factorizing, you'll get the first turning point is x is 3, while the second turning point is x 1 over 3. Now, we already know that for this one here, the y-coordinate of the turning point is 0, right? We got it up there. For this, we actually need to substitute, right? But to get the y turning point for this, it needs to be substituted in the original equation. Okay, so I'm writing negative 1 over 3 plus okay, so this is negative 256 over 27. There we go. Negative 256, negative 256 over 27. Okay, so let's put this in our graph because I need to explain a couple of things on our graph up there. This is 1 over 3 and negative 256 over 27, right? So that's the coordinate of this turning point over here. Now, going back to the question one more time, it says, so the equation of f of x minus k plus 3 is equals to 0 has 3 real roots. What are the possible values for k? Now, this here, 3 real roots, means that it has 3 x-intercepts. Looking at our graph here, we understand that we only have 2 x-intercepts, which is here and here. Now, if we want 3 x-intercepts, it means our graph needs to be shifted, right? It needs to be shifted vertically. Now, this part of our graph here, which I'm going to highlight, this part of our equation here, is the amount of units our graph needs to be shifted upwards or downwards to achieve this 3 real roots. That's exactly what we need to look at. Okay, so coming to our graph again, our graph here has to be shifted vertically. Now, if you shift your graph downwards, a couple of units downwards, you will notice that you would only have one x-intercept, and the only x-intercept you would have would be over here. This other x-intercept would be below the x-axis line, making only one x-intercept. Okay, so if you reverse that and move it upwards going like this, what would actually happen to our graph is that we're going to have 3 x-intercepts. So basically it's going to look like this. If I just draw a simplified version of this, I move it just a couple of units upwards, our new graph is going to be like this. Very similar, right? So as you can see, I would have 1, I would have 2, and I will have 3 x-intercepts. Okay, and that's what we want. But there is a limit to this, actually, and the limit is this. So we cannot move it past here. Yeah, and that limit is me moving it from this to there. You see this turning point that I have here as 1/3 and negative 256. If I move it more than 256/27 units upwards, it will move into the territory of just having one x-intercept. Because if I continue moving it past here, let's say I go one more unit after this, you will now see that it is only going to have one x-intercept. Okay, so the limit I'm looking at is from where my graph is currently to the yellow line. That's what I want. Anything within that range, right, I'm going to have 3 x-intercepts, and in turn it means that I'm going to have 3 real roots. So how do I represent that? So how we normally represent that is this. Since we said here that negative k plus 3 is the vertical shift, we could actually say that negative k plus 3 must be greater than 0, because we actually need to move it upwards. But there is a limit to this. This negative k plus 3 has to be less than 256/27 units. You cannot move it past that amount of unit, or else you go back to just having one real root again, right? So simplifying all this is what it's going to give you. For this one here, you're going to have negative k is greater than negative 3. So therefore, you would have k is less than 3. And for this one over here, we could say that negative k is less than, so we move 3 over to that side, meaning that you're going to subtract. So real quick, let's do that. 256/27, right? Minus 3. That's 175/27. So it should be 175/27, okay? And when I divide by k, I'm going to get k. I'm going to get k is greater than negative 175/27. Okay, so now your k is less than 3 but greater than that value. So we can just combine them to actually look like this. K is definitely less than 3, but this here, I could actually put it this way. Negative 175/27 is less than k, but k is less than negative 3. And this would be your answer. That's it. Question 12. This question says, in the diagram below, the graph of f prime x is sketched for x is an element of real numbers. Now, O represents the origin. We have this straight line graph which represents the derivative of fx, right? F prime x. Now, they asked us write down the gradient of f at x equals to 0. Now, whenever they ask you for the gradient of f, it's a fancy way of saying that they want this, okay? But not just this, they want this, right? The derivative at x equals to 0. And from what we can clearly see here, when x is 0, this value here is 15. So your answer here is just 15. Okay. For B, it says down, write down the x coordinate of the turning point of f. Now, we also know this, that the x value of your turning point of fx, it is equals to the x-intercept of the derivative. Okay, so if that's the case, I just need to look for the x-intercept, and this here is 10. So for that reason, our x-coordinate of a turning point will just be x is equals to 10. Okay. For C, they ask you what is the gradient of f at x is equals to 1. Now, to find this, we first of all need to figure out what the derivative of fx is. Now, after figuring that out, then we also now need to substitute 1 into it, and it helps us get our answer. Okay, Since our graph of our derivative is also a straight line, what we can do is to get the equation of a straight line, right? So make our equation look like this. So y is equals to mx plus c, okay? So what I'm going to do with this, so I'm going to find my gradient, then find my y-intercept, which represents the c. So the gradient here, so the gradient would be 15 minus 0 over 0 minus 10. Okay, so when you get this here, this would be 15 over negative 10, which is negative 3 over 2. Okay, so my equation would be negative 3 over 2x, and since the y-intercept is 15, I think, right? Yes, it is 15. You have plus 15. Now to get this, because this is actually what we want, we just need to substitute 1 into this. And substitution of 1 would be negative 3 over 2. Then we have 1. Okay, plus 15. And that's 27 over 2. Okay, so this here will be the gradient of f at x equals to 1. And the last question asks us to get the point of inflection. And the point of inflection is your second derivative is equals to 0. Okay, so we already know that our derivative, that's the first derivative, is equals to negative 3 over 2x plus 15. And if we differentiate this, so our second derivative will just be negative 3 over 2. Since to get your point of inflection, you need to equate this is equals to 0, and that is not possible, we would actually say there is no point of inflection. Okay, or no solution, or however you want to represent it. There's no answer for this, and that's exactly what they want. That's it.